and he's an expert in Java, and he also has been training in a big data Hadoop for the last 4 years as well. And with TechieBees, well, he has done more than 20 plus batches for big data Hadoop developer itself. And he also is an expert in Apache Spark and Scala and Hadoop admin. So now I will let Srinivas take over this training program. Srinivas, it's all yours. Thank you so much.
Yeah, good, Sunil. Thank you. Thank you for the introduction. Yeah, hi, good evening, friends. Good to see all of you. I appreciate your interest in taking up this demonstration on big data. Before we move on to the actual discussion on big data, I would like to get inputs from your end. What is your perspective towards big data? Please feel free to unmute yourself. And this is not to evaluate you basically. This is only to make me to understand what is the right way to give this demonstration. Yeah, please.
Can I speak?
Yeah, please, absolutely.
Hello. So it's the amount of data that is beyond the capabilities of a single physical machine to handle or process.
That's a very convincing answer. I appreciate it. So when
Thank
you
you.
say that beyond the capabilities of a single machine to process, you say, can I call my laptop to be a single machine, and beyond the capabilities of my laptop, any data, we call it as a big data? This is what my laptop, hope you're all able to see my screen. Is that correct? Are you able to see my screen, friends?
Yes.
Okay.
Yes.
Well, I'm writing something with my writing board, so I just want to confirm whether you're able to see that or not. So, as been mentioned by Hina, um, this is what my laptop, and beyond the capabilities of my laptop, if I need to store some data, that is what we call it to be big data. Can we confirm this? This is only to make us to understand there is no debate or there is no verification of this one. This only to make us clear, because whenever you hear the term called big data, you also will be hearing the term called Hadoop. So until and unless we are clear with what is big data, what is Hadoop, in what way your big data is connected to Hadoop, if at all, if there exists any relationship, what kind of relationship that exists between big data and Hadoop. If no relation, that's a different story. But if at all, if there exists any relation, what kind of relationship that exists between big data and Hadoop. So until unless we understand all these things, it will be tough for us to continue our journey. That is the reason why we have planned this demonstration to make you to understand few things. That is, what is big data? Then how big data is connected to Hadoop. Then we see Hadoop ecosystem, what other components you have as part of Hadoop ecosystem, and then the details about the course, and if you have any questions, we'll be having probably at the end. This is how this demo is been planned. So you expect anything beyond this, please let me know. We'll try to discuss those things even probably after covering these. Probably the next 30-35 minutes, we will try to see all these aspects in a decent fashion. Once we are done with that, then we will have discussion once again to see anything more required from my end to make you clear with the concepts of big data or to continue with this course, right? That makes sense, friends? That makes sense?
Yes.
Wonderful. So let us start with the discussion. What is big data? I really appreciate the answer that is being given by Hina. I don't debate on that, but at the same time, it is good on our part to understand what is big data in its true meaning. It's always a good idea that if we fail to understand something on its own, say we try to understand what is big data. If you fail to understand what is big data, never mind. Try to understand what is data first and add big to that one. You will be able to understand big data at a easier level. We all know very well, because why I am stressing on this point called big data is for the reason big data is not a framework. Big data is not a technology. Big data is not a software. Big data is not a platform. Then what is big data? Without we understanding that, understanding the relationship between big data and Hadoop will become a big challenge for us. So we just use the terms like how many people who are even working in the industry, they use these terms in an interchanged manner. We'll be one among them. That is the reason why I thought, let us get clarity on these fundamental aspects to see how big data can be defined well and how to establish the relationship between big data and Hadoop. So as a part of this one, I would like to share with you, friends, as been mentioned by me here, let us try to understand what is data. Once we are clear with that, we'll think about how we to add big to that one and understand big data. Have a look at this slide. You'll be able to understand from this slide. I think you see the slide what I'm showing you here. At the very lowest level, you have something called data that signals no nothing. When this data is processed in a given context, that gives information to you. And this information is definitely useful. It is organized and it is structured. When this information is further processed, we get knowledge. And this knowledge, when it is further synthesized, we get wisdom. With wisdom only, we make decisions. Either right or wrong, forget it. but with wisdom only we make the decisions. So in order to make decisions, we need wisdom. Without wisdom, we will not be able to make decisions at all. Right? If there is no wisdom, the chance of taking decisions is almost obsolete. That is where I say this is what we popularly call it to be DIKW model. DIKW model. Data, information, knowledge and wisdom. DIKW model. If there is no data, there is no information. If there is no information, there is no knowledge. If there is no knowledge, there is no wisdom. Without wisdom, we will not be able to make any decision. This gives us a clear understanding. Data is essential or crucial. Data is, with this slide, I want to bring it to your notice. Data is essential or crucial or very important, without which nothing of this exists. Information will not be there, knowledge will not be there, and wisdom will not be there. So, before understanding big data, we have understood data is very, very important. And what is data basically? Data is anything which is raw, unorganized, that is expected to be processed. The same when it has been processed, we get information. The same when we process, we get information. You look at this small example, each student's test score is one piece of data. Each in a class of 30 and a school of 500 students, if you see, each student's test score is one piece of data. And that may not be much informative to anyone, either to the class teacher or to the school principal. But the class average score or the school average score is information that can be concluded from the given data. That makes more sense. The class average score or the school average scores makes more sense to the class teacher or to the school principal in finally making some decisions. Right or wrong, that I'm not talking here. But to make decisions, this forms the base. So it has been clearly understood. Data is very important and we have understood what is data basically. Data is raw, unorganized facts that is expected to be processed. The same data, when it is processed, we get information. I hope you are clear with this one. To the same data, if you add big now, you'll be able to understand big data. That is how industry has standardized the definition. Because when you look at the term called big data, if everyone comes out with their own definition or perspective, then it is tough for the people to follow what is big data. That is the reason why industry has standardized the definition for big data. Look at this one. You will be able to understand. Big data is anything. Big data is anything which has three essential characteristics. Big data is anything which has three essential characteristics. What are those three essential characteristics? Volume. Big data is anything which has got three essential characteristics. What those three characteristics are? The three characteristics are volume, variety, and velocity. These are what we popularly call it as 3 V's. Volume, variety, and velocity are the 3 V's with which we define something called big data. Volume, variety, and velocity are the 3 V's with which we define something called big data. Of course, these V's are getting extended from time to time. You have something called value, you have something called veracity, you have something called viscosity. These are getting extended, but these are the 3 V's with which we define something called big data. Volume, variety, and velocity. You look at these things closely now, and velocity. You take volume, you understand, compared to the books what you have in your shelf, these may be more in volume. This makes you to understand, volume is always a relative. It is not absolute. There is no such thing called absolute volume. I mean, when you have only this much of data, then only we call it as volume. No, volume is always a relative term. Compared to the data what you have on your laptop, my data may be less or my data may be more. It is all by comparison. There is no such thing called absolute. So we need to understand what is the impact of this volume in your real life. The impact of this volume is, see here, the data that is coming into the organization every day and the ability to process the data with your existing infrastructure. If you see both of those things closely, you need to understand here the data that is coming into the organization every day is getting increased. But the ability to process the data is coming down day by day with the existing infrastructure. So every day there is some amount of data that is left unprocessed. And till you process the data, you should feel that there is a valuable information inside it. That is the reason why I mentioned there may be gold inside this. Whatever the gap that is getting arised between the data coming into your box and the ability to process the data, that gap is what we technically call it to be blind zone. The data that is available to the organization or coming into your landscape every day, that is getting increased. You can estimate easily, friends. Even you see your case, personally your case, the amount of data that you collected last year, that is 1st Jan 2016 to 31st December 2016, you roughly estimate how much amount of data you might have gathered in different forms, a rough estimation. Maybe in the form of taking the photographs, downloading songs, downloading documents, various softwares that you downloaded, you worked, all that you calculate, how much amount of data that you might have created or you have acquired last 1 year. And if you see from this year first till now, you might have already surpassed that amount. In the case of an individual like you or me, when data is growing exponentially, I need not talk about the exponential growth of the organizations day by day. When the data coming into the landscape of the organizations increasing tremendously every day, and the ability to process the data is coming down day by day, there is always the data that is left unprocessed. And we expect we expect this blind zone needs to be eliminated completely. If not possible, at least try to see this gap is kept at the very minimal level. So the impact of the volume is, the first impact of the volume is when the data that you are getting into your landscape is growing enormously, where we store the data. When you're getting a huge volume of data, that is what Tina has mentioned in the beginning, beyond the manageable limits of individual machines kind of thing, then where you store the data. I only talk about storage first because until unless I store the data, I will not be able to think about my processing. Processing comes into picture only when I am able to successfully store it. When I am able to store it successfully, then only I can think about processing the data. Then only I can think about processing the data. Then only I can think about processing the data very fast. But without me storing the data, thinking about processing or fast processing or lightning speed processing is meaningless. So the question that arises here is where we store that huge volume of data. Where we store that. That is what the question here. And coming to the next one, you see the variety. You have hundreds, thousands of varieties of data available in the real world. You see closely this one. Alone in the image format, you have GIF, JPEG, PNG, BMP, varieties of data alone in the image format. You see, when you have your data available in numerous formats, your storage should not put a constraint. Your storage should not put a constraint saying that I allow only this kind of data to be stored. Because if you take your traditional databases, you see what you have defined, only that data is allowed to be stored there. You try to give any other data other than what you have defined during your table creation, you are not able to store the data inside your database. But whatever the data that we are getting from the real world, when it is coming in, it could be your structured, unstructured, semi-structured, whatever the data. If it is structured, we need not worry about how to store. We already has got a lot of solutions. We can. But in the case of semi and unstructured data, and that to be they come in different varieties of forms. Many of them are proprietary and most of them are open source. There should not be any constraint that only this kind of data is allowed here. Other than this, the other data is not allowed to be stored. I should not have a constraint. My storage should work like my normal hard drive. You see, on my laptop here, maybe in my D drive, I go to some work directory. I should be able to store all my data here. Is your hard drive putting any constraint? Absolutely no. Let your data be anything, you'll be able to store it on hard drive. So I need a storage even at my enterprise level that should not put any constraint to me saying I allow only this kind of data to be stored. I need that kind of storage, not the storage which allows me to store only predefined formats of data. So what is the second thing that we are coming across? The second thing that we are coming across is where we store varieties of data. Where we store varieties of data. So if you observe closely these two things, you should be able to understand one thing, that is, you should be able to understand one thing. Both volume and variety are linked up with my storage. Both volume and variety are linked up with my storage. Where we store huge volume of data, or how we store a huge volume of data, and how we store wide varieties of data. Both linked up with your storage part only, right? And coming to the third one, that is what we call it to be velocity. Look at this diagram closely. You should be able to understand the rate at which the data is coming into my box. If I am not able to process the data at the same rate, I will not be able to share meaningful information with my end users. That is the reason why I have shown you this specific diagram. You can look at the use case now. Though it is a routine example I share with people, but this is a very classical example. Imagine that you have switched on the TV, someone reading news on the screen, and they are saying like this: today there was heavy rain. Does this make any sense to you? Today there was a heavy rain in the city. Today there was heavy rain in the city. Does it make any sense? Because we already enjoyed it. We already experienced it. We already underwent the pain. We felt that inconvenience. It doesn't make much sense to listen to the informations that are today there was heavy rain. We already experienced that. But it makes more sense to me. The same newsreader is reading the news in such a way: tomorrow between 10:30 a.m. to 11:30 a.m. there is a possibility of heavy rain in these parts of city. In these parts of city. Please look at this one, friends. Tomorrow between 10:30 and 11:30 in the morning, there is a possibility of heavy rain in these parts of city. That makes more sense to me, because if I have planned to go out that time, either I postpone it. If it is mandatory, I am well prepared for that. So this makes sense. You look into this diagram back, the rate at which the data is coming into your box, at the same rate, if you are able to process it, you'll be able to give meaningful information to the end users. Otherwise, you'll not be able to give the meaningful information. There is no point calculating the impact of tsunami, how many people died, what is the property loss. Calculating those things after tsunami doesn't make much sense. If you are able to predict the impact of tsunami well in advance, you'll be able to take the necessary measures, and you are well prepared for that, so that you can control the damage that can happen. Of course, it is not possible that no damage happens at all in these kind of big natural calamities, but still things can be kept under control. I hope you are able to understand. The third V, that is called velocity. Velocity says how to quickly process the data. How to quickly process the data. Quickly, I mean rapid. I mean almost like lightning speed. Data comes and it gets processed just like that. It is not that data comes to me today, I take 24 hours time to process that, then only I'll be able to share the details with my customers. It will not make much sense. Maybe in few cases it may make sense, but in most cases it may not make sense, because we always need the contemporary data, not the data that is old. with the current trend going on, I should be able to predict what is the stock that is going to perform well today. Then I'll be able to give that information to all my customers. Today, invest in this stock. And your predictions need to be so precise. It should be beneficial to your community by large. So how to quickly process this data? Now tell me, friends, what is big data? Now, please tell me what is big data. Are you able to hear me, friends? Yeah.
Yeah. Can I say?
Yeah, please, Hina. Yeah.
So the big data is the amount of the big volume of data that is coming from the variety of sources and the variety of formats and with great velocity to be processed simultaneously as we receive the data.
That's really very convincing and I appreciate. So can we say, Hina, that big data is a problem statement? Can I say big data is a problem statement surrounding storage and processing? Can I say like that? Because big data is questioning me, right? Big data is questioning me how and where we store huge volume and wide varieties of data. You agree with me?
Yeah.
And big data is also questioning me how you can quickly process this stored data. You agree with me? How you can
Yeah.
quickly process this stored data. How you can quickly process this data. So it is very clear now. It is very clear now that big data is a problem statement. It is not a framework. It is not a technology. It is not a software. It is not a platform. It is just a problem statement. To this problem statement, you have a solution called Hadoop, which internally has got HDFS and MapReduce. Your HDFS is to address your storage problem. Your MapReduce is to address your processing problem. This HDFS is what we call it to be Hadoop distributed file system. It is a file system which is distributed and specific to Hadoop called as HDFS, with which we can store any amount of data practically. Any amount of data. Because with Yahoo, as of now, we have a 50,000 plus node cluster. It is growing still. Your Hadoop is able to manage. As and when your need for the data storage increases, you just need to add more machines to your cluster rather than improving the capacity of each machine. That is where we have two architectures. One is a scale out architecture, scale out. The other one is scale in architecture. What do you mean by this? What do you mean by a scale out architecture? What do you mean by a scale out architecture? When you want to store a 4 terabyte data, when you want to store 4 terabyte data, instead of you thinking about producing a hard disk of 4 TB, it is better that your 4 TB data you cut into 4 parts and store 1 TB on each hard drive. That is called scale-out architecture. Instead of you thinking it is a good thing, it is not the story that we are learning now. This is the same old story what our ancestors are following for the last 10,000, 20,000 years. When a ox need to pull a very heavy wooden log, imagine this is a very heavy wooden log. When one ox not able to pull this wooden log, our ancestors never dreamt of increasing the size of the ox. Instead, what they have done is they have added one more to the existing to pull that log. If two also not able to pull the log, then I will be adding the third one, fourth one, fifth one, sixth one. I keep adding so that I'll be able to pull the log, the heavy wooden log. That is what I mean by the scale-out architecture. Don't worry, friends, we talk about all these things very in detail as part of our program, but this is just to make you to understand. Just to make you to understand, my HDFS is going to address my storage need. My HDFS allows to store any amount of data, any variety of data. Because it is not like your enterprise data warehouses where the storage is being defined. It needs to allow to store only that data. That kind of restriction is not there on your storage. It is just like your hard drive, how it allows any kind of data to be stored on it. Same like your HDFS is going to allow you to store any variety of data of any volume. And my processing is going to be done very fast with the help of MapReduce programming model, which is backed by massive parallel processing. Massive parallel processing. Parallel processing is a technique on which your MapReduce framework is built. So Hadoop is basically a solution to the problem called big data. Now I think you are able to understand, friends, what is big data and what is Hadoop and how both big data and Hadoop are connected to each other. Hadoop is just a software framework with which you are able to manage large data sets residing in your memory and able to quickly process this one with the help of a simple programming model called MapReduce. I think you are able to understand now, friends, what is big data, what is Hadoop, what relationship exists between these two. Make sense? You refer any document, you go through the web, anywhere you see, you will not be able to find this kind of a discussion or document, because I don't blame people that, Srinivas is the only person on this planet who is able to define big data and Hadoop and establish the relationship between big data and Hadoop. In many cases, it may not be possible to give this kind of explanation theoretically. So it requires some kind of practical, discussion and, surrounding many things to give you that feel what is big data and how your Hadoop is connected to big data. This is possible only with these kind of discussions, not in the form of a document or something like. Even if it is being given, we will not be able to give much clarity on that. Like how we are able to give during the live instructor-led demonstration or instructor-led sessions. So I hope you are able to clearly understand this one, friends. You have any question, please let me know. We try to work on them before we move on to the next point. So what is big data now? Big data is anything which has got three essential characteristics: volume, variety, and velocity are the three ways with which we define something called big data. And how this big data is connected to Hadoop, I think you are very clear how big data is connected to Hadoop. Hadoop provides an open source solution. Hadoop provides an open source solution with which you are able to store any volume of data and any variety of data and able to quickly process the data with the help of MapReduce, which is a programming model, with massive parallelism in its back. That's how your big data and Hadoop are connected to each other. This makes sense, friends? Hina, Arun, Shahul, Jamal, are you able to understand this one, friends?
Yes.
That's wonderful. That's wonderful. Convinced. So you have any questions to me, feel free to ask. That's fine. No questions, we move on to the next one. So as part of the Hadoop ecosystem, if you see closely, it is not just storage and processing, we have many more. That is where you see the big data ecosystem. At the very lowest level, we have storage. On the top of storage, we have processing. And on the top of processing, we have data access, where peak hive and all these things comes under data access. And on the top of data access, you have something called data management. And finally goes to your data analytics. If you observe closely all these things here, it is all surrounding the concept of data. It is all surrounding the concept of data. Storage, processing, access, management, and analytics, all surrounding the concept of data. So data is a very crucial and essential thing to any organization. I hope you understand. Facebook, you take the case of Facebook. I don't know really the worth of Facebook. I'm taking an example here. I really don't know. Net worth of Facebook. You see here, it is $190 billion. Roughly, I mean, maybe it may be more, slightly more or slightly less. That's a different story. Tell me, in last 10, 12 years, Facebook has grown from 0 to $190 billion. Does it mean they have huge offices and they invested heavily on all these offices and there are lakhs of people working for Facebook? That is the reason why the worth has increased. They have more assets, physical assets. That is why the company's value is now at $190 billion. They have hardly few offices globally, and they don't have people working in lakhs. But still, its worth is $190 billion is only because of the reason the huge data on which Facebook is sitting. That is the main asset to the organization. So of course, this is a fundamental thing to any organization, but these days it is becoming crucial that data forms a key factor during your valuation. I think many of you might have heard, friends, there is a company called Paytm in India. Paytm in India, you see, Paytm till date hasn't made even one single rupee profit. But still, when the same Paytm is been sold recently, 1% of his stake been taken out by. Are you following with me, friends, what I'm sharing here? Friends, are you able to understand what I'm saying? Paytm till now didn't made even 1 rupee profit, but still, when the founder of the Paytm sold his 1% stock, he made 350 crores, estimating the value of Paytm at 3,500 crores. How come is possible? Is all because of they are sitting on huge data of almost 700 million people. 700 million people data is on what your Paytm is sitting. That is why its net worth is going at that level, which makes you to clearly understand data is a crucial thing as part of any organization, friends. So without data, you don't have anything. That is the reason why we are focusing or we are revolving around the concept of data, how you store, how you process, how you access, how you manage, and how you analyze. This is what we call it to be my Hadoop ecosystem. Hadoop ecosystem. So I need not tell you, friends, as part of our course, what we are going to learn. We definitely need to learn about storage. We definitely need to learn about processing. In Access, we learn about Hive, Pig, Scoop, Avro, except Mahout. Mahout is actually machine learning, which is not been covered as part of this program. And almost all the remaining things we see. When it comes to management, we talk about Flume, Zookeeper, and Uzi, because AWS, EMR, and all those things related to AWS. So we will not be discussing those things. But Uzi, of course, Chuko also will be looking at Flume, Zookeeper. You know very well that this program is for Hadoop developer, not analytics. So data analytics we will not be seeing as part of this program. But yes, 1 or 2 sessions, depending on the need, we will be working on analytics part to understand how our process data can be used by the analysts as a data engineer or as a Hadoop developer. Whatever the data I am processing and giving it, how this data is further used by the analysts. Without me understanding that one, I will not be able to produce right data as a data engineer or as a Hadoop developer. That is the reason why we need to think about data analytics to a certain extent. So as part of the course, now I think you understood what all the things we are going to cover. So I hope you are able to clearly understand, friends, what all the points that are being covered here. What is big data? How big data is connected to your Hadoop? And what is Hadoop basically? Hadoop, whenever I use a term called Hadoop, I implicitly mean by HDFS and MapReduce put together. Whenever I use a term called Hadoop, I implicitly mean by HDFS and MapReduce. What components you have as part of Hadoop ecosystem, and as part of the course, what we are going to see. And these components are going to be covered very in detail, showing you the executions on the real cluster. Of course, we are going to set up environment for every one of you on your laptops, and apart from that, to give you the feel of how in reality things happens. Of course, there is no difference between your pseudo cluster and a fully distributed mode, except your replication factor. Rest of all the same things that you see in the pseudo cluster and the fully distributed mode. We have multiple clusters with us depending on the need. I will be using one of those clusters to demonstrate you how the same data what you are processing on your local machine, how it can be processed at your cluster level. We'll be seeing that one practically. Then we'll be able to understand how we can make these things happen, how we can make the realistic aspects happen. So as part of that one, I would like to demonstrate how your cluster is going to be, You see that here, how your cluster is going to be. This is what my manager, with which I am going to manage my Hadoop cluster and see the health status and how each node is functioning, what are the hosts that are available, what are the hosts that are available to me. All these are the nodes that are available in my cluster with different IPs. I think you are noticing here. All about my Hadoop administration part, how I manage my cluster. Same like how I work with my data as a developer. We'll be seeing as part of Hue and see how we can work with our HDFS and how we can work with our jobs. You develop a job and you submit that to the cluster, and how the cluster is working with you can see that here for the user called Srini, what all the jobs that are being submitted and how those jobs are being executed and how much each job is working in the background, what are the mapper tasks that are functioning in the background, and what are the reduce tasks that are functioning in the background. All those details you'll be seeing precisely on a live Hadoop cluster. We have an 8 node cluster, we have a 6 node cluster, we have a 5 node cluster. We have multiple clusters depending on what we need. We'll be working with one of these clusters to understand the same aspects what you're learning applicable even when you go to the workplace. Our course is purely aimed at the practical level, not our course is not going to run by PPT. PPTs are going to help you out only in giving you the concepts, but PPT is not our criteria at all. 90% of the class, what you take every day, they're all practical. The reason behind that one, see, when you're able to see something happening live in front of you, you'll get energized. When Srinivas is able to run the code what he developed in the class, when he is able to run, even that is possible with me. I just run the PPT and push off from the session. We also think virtually. We never try or attempt working with the aspects at that level, right? That is why all the sessions are being planned practically so that they can give confidence, motivate, and energize you to take things further, right? So that is all being planned as part of the program. So you have any questions now, friends? Please feel free to ask so that I'll be able to answer those things. Have any questions, friends? Or feel free to ask me anything that you are expecting from our end. This is what I thought. I don't want to make my demonstration more clumsy. That is the reason why I took very few points. I want you to clearly understand what is big data. Big data is a problem statement. And this is being well addressed using your open source solution called Hadoop. And how this big data and Hadoop are connected, we are able to see the relationship. And what components you have as part of a Hadoop ecosystem. And we talk in detail about those components time to time. That will be more meaningful. You have any questions on the course or on big data which you feel that I can address, or you want them to get resolved before you decide to go ahead with the program? Feel free to ask, friends, anything that comes to your mind which you feel needs to be addressed by me. Any questions, friends?
I have one question, please.
Yeah, please don't hesitate. Yeah, anything that you feel is needed, please don't hesitate. Please clarify. Yeah.
Okay, I have heard that there is a need of using Java programming in some part of the Hadoop thing. So can you tell me where we use the Java?
Basically, we use Java only in writing the MapReduce programs. Mainly, when you're writing the MapReduce programs, we use Java. And a part of Java we'll also be using when you're writing your UDFs, I mean user-defined functions in Pig and Hive. When you are customizing your Flume with your own Flume sources and all, we may be working with Java. When you are customizing your other components as part of the ecosystem, and when you want to use the existing API and develop something better than that, then probably you'll be taking the support of Java. It is not mandatory that without, of course, as basics of Java essential, we are taking care of that one. You need not worry for that. So without Java, there is no much harm to you across the Hadoop landscape. But I can say confidently, if you have sufficient knowledge on Java, that is always an advantage point to you in terms of the interior or in terms of your career prospects, right? In fact, your entire Hadoop ecosystem is built on Java only. Your Hadoop itself is built on Java. Your Hadoop itself is been built on Java. So Java has got its due importance across, and it is how we can master Java, because Java is an ocean. It is an ocean, endless, right? But basics of Java sufficient, like inheritance, polymorphic behavior, exception handling, streaming, and collection framework, and very few or little basics of JDBC. I mean, how you can establish a connection with databases and all. Only basics. Is that fine, Jamal?
Yep.
Any other questions, friends? Hope you enjoyed the demonstration, because I thought of making it simple, sweet, and easy to understand, and get clarity on the fundamental aspect. That is the reason why I thought. Because I don't want to overload you, showing you many things and mess up the things and confuse what to do now, and what is the right path to choose. That is all not. Because you want to be a data engineer, even you want to learn Spark and Scala in the coming days, without you undergoing this data Hadoop developer or data engineer program, you'll be able to do it, but it is something like Greek and Latin for us. Have any questions, friends? If no questions, we end up at this level. Probably my team is going to coordinate with you to schedule the sessions and update you the details about the program, how it runs, and what days the program is going to be, and how many hours each session. All those precise details will be shared by either Sunil or Ilyas or someone from my team, so that it becomes easy for you to um, decide. Yeah,
So I have a question.
please. Yeah.
So I'm asking, without having any experience, so where would I stand in the industry
See,
with job?
as you have looked into the aspect what is been discussed now, okay. So even if you don't have any experience, industry experience, to be a
Mm-hmm.
data engineer, I share like this. You have three roles altogether. So data engineer, data analyst, and data scientist. Data engineer, data analyst, and data scientist. If you look at this diagram very closely, to be a data engineer, you need not have any experience in the industry. The only thing that is needed is You need to have the wish or will to master the subject. So no much prerequisites for this one except basics of Java, basics of SQL and all. But when you go to a data analyst, at least you require domain knowledge. I don't say that you need to be experienced, but you require domain knowledge. Usually we acquire domain knowledge only when you work. And data scientist is not the position which you get by attending some course. Data scientist is the one who understands both data engineer and data analyst and has got his own perspective towards that. So data scientist, yes, definitely prerequisites and time needs to be spent on that. And that is only over a period of time, not instantaneously now. But data engineer and data analyst, even without much knowledge, will be able to survive or will be able to move forward. But at least to become a data analyst, we need to have some fundamentals of very fundamentals of domain, without which you cannot be an analyst in the domain. So you want to be a stock analyst, you need to be good at stock, right? Understanding stock, every term related to stock and all, you need to be very clear. But in the case of data engineer, there is no such thing like a prerequisite or experience or something of that sort. Make sense, Hina?
Yeah, so most of the people who are already in the industry, having some other experience in the IT field, so they are also turning towards the big data, Hadoop. So even they have
Yeah.
they all,
But
I'm sorry.
usually, but yeah, you rightly said, usually, I mean, because that is a part of internal transition, because every organization these days coming into big data. So usually, instead of me taking an outsider, I always prefer to
Yeah,
give knowledge to my internal resources and move them to my big data. Usually that happens, right? But may
yeah.
not be in every case, usually. So I don't think you'll have any bottleneck to go into the industry as a data engineer without any prior experience. Even as a fresher, you can take up data engineer, even as a fresher, right? So there is no such thing. But as you rightly said, you know very well that the industry is always like that. I come to know about the opportunity when I'm inside the company. When I feel that is more lucrative, so I definitely will opt that one. So the opportunities are usually consumed by the people internally. Um, that is the reason why they are going in the transition. But otherwise, there are many openings even for the people who are well comfortable with the technology framework and also comfortable with, I mean, also did certifications kind of thing, right? So I don't think that will become a bottleneck for you.
So should we have an IT, the masters in computer science for this?
Not at all.
Okay.
Not at all, because the only prerequisite to learn Hadoop is to have a minimum knowledge on Java, minimum knowledge on SQL, and basics of your Linux commands. That's it.
I'm sorry, what was the last third one?
The basics of Linux. I mean, that we are going to see as part of our session itself, but basics of Linux, because you are going to work with HDFS. HDFS is very much similar to your Linux kind of thing. Same commands will be working even here. Like how you are going to use ls kind of command at your terminal. Same like when you come to Hadoop, instead of you saying ls directly, you will be saying Hadoop fs ls. So very basics of Linux will help you out in working with your HDFS commands. Even if you are not good, probably 1 or 2 days you'll be practicing on Linux commands, then you can comfortably work with your HDFS commands.
Okay.
So no, this is not to convince you to bring you to the program. Because I
Yeah.
know very well, tomorrow you come to the program and you face the challenges, I am the one who need to face that. The only prerequisite for this one is you should have interest to learn and work with many examples. Then I'm sure you'll be able to set in the big data space without much difficulty. Even if you work hard now, tomorrow you can also, with good experience and expertise and the skill levels what you acquire now, you can also project or profile your resume with 3 years of experience, provided you are able to prove that yes, you are like a 3 years experience person, provided you have the sufficient knowledge, right? The only thing is you need to have interest, understanding data and process it.
Thank you.
Yeah, good, Hina, good, appreciate. So hope you got something out of the today's discussion, friends. I don't say that I was able to transform you into big data. I don't claim that, but I think definitely some information you might have got. At least what the points that I've mentioned, you are very clear with those things. Usually, I start with an agenda and I see that is been achieved or met that day. So that will be more effective in making up your things. And time to time, we are going to share all the necessary documents related to your um, developer program. So with minimal effort, you'll be able to master this subject with minimal effort, because our experience in Hadoop and the experience in taking classes globally on Hadoop components, on different Hadoop components that includes Spark, Scala, MongoDB, Cassandra. Of course, they're not directly related with big data, but yes, when it comes to the storage, we can also look into those things. So having a good experience and exposure towards all these things, I'm sure that will be helpful to you to make up your learning process more easier and simplified. And we don't have any mechanism here. Demo is taken by Srinivas and classes are handled by someone else. No, you're going to take all your classes will be taken care by me. And time to time that information is shared with you so that you'll be able to access those links and attend the meetings and work with the content what we are going to provide to you time to time, right? Wonderful, friends. I appreciate your presence today. Have a great day ahead, and probably Sunil or Elias, one of them will be in touch with you to understand any of your specific needs, but don't hesitate to bring it to our notice before you make a decision to be a data engineer, right? Wonderful day ahead, friends. Love to see you back as part of our program.
Thank you.
Thank you.
Wonderful, friends.